Many words interpretation simply multiplies realities. We lose a spectrum. Everything is true in the sense of all possible variations are true. So and in some sense, what fascinates me, the ontological incompleteness, again disappears. Everything is fully there. The problem is our limited standpoint. Am I missing something here?
Yeah, so I'm happy about this one because you are missing something, and I can help
let's go
a little
where
bit.
I like you. Yeah.
Hello, my geeslings. It is Mother Goose, Robinson Earhart, here with the podcast and the introduction to Robinson's podcast, number 118, which incidentally confirms that we are on a very strange branch of the wave function because my guests are Slavoj Žižek and Sean Carroll. And I will keep their bios short since everyone knows them. But Slavoj is International Director of the Birkbeck Institute for the Humanities at the University of London and a senior researcher at the University of Ljubljana's Department of Philosophy. He was also the guest on episode 109, which was all about psychoanalysis, wokeness, racism, sexism, Nazis, Curb Your Enthusiasm, and 100 other things. It would be impossible to encapsulate all of the topics that we cover without talking for 90 minutes, the length of our episode. But Sean Carroll, on the other hand, is actually a quantum physicist. He is a cosmologist, a philosopher. He's Homewood Professor of Natural Philosophy at Johns Hopkins University and fractal faculty at the Santa Fe Institute. He's also host of Sean Carroll's Mindscape, which is an absolutely terrific show. I love it. I've listened to every episode on science, society, philosophy, culture, arts, ideas, and anything else Sean has been thinking about. But Sean, along with David Albert of Columbia, was a guest on episode 106, which covered the many worlds theory of quantum mechanics in great detail. And then we also talked about entropy and the enduringly fascinating topic of Boltzmann brains and then the fine-tuned universe. But in this episode, I am, as Slavoj refers to me, merely the middleman and a wallflower along with pins. And so I don't do much of the talking. So Sean and Slavoj, while I giggle in the background, do talk about quantum mechanics, the indeterminacy of small-scale reality, cosmology and the Big Bang, some major figures like Niels Bohr, Einstein, Stephen Hawking, and then the world of sci-fi, including movies like Everything Everywhere All at Once, Indiana Jones, and The Avengers. And now one thing that I really have to mention, so pay attention now, is that Sean Carroll is an honorary fellow of the John Bell Institute for the Foundations of Physics, which is directed by another Robinson's podcast alumnus, and that is Tim Maudlin of NYU. It's at this point still very much a nascent organization trying to secure its home, and it is meant to give a home to many of the topics that we discussed today and really has the who's who in the foundations of physics as contributors. And the JBI can really use any donations at this point in their early history. I've donated once and will certainly donate again as soon as my meager budget allows it. So anything you contribute will be greatly appreciated by the JBI. And finally, there are links to Sean's website, Sean's Twitter, and the biggest ideas in the universe in the description. So without any further ado, I hope you enjoy this wide-ranging conversation as much as I didn't so much have it, but got to enjoy listening to it as it happened myself. Slavoj, you're very well known for thinking about a lot of topics. Marxism, psychoanalysis, and Hegel come to mind, but quantum physics isn't one of them. So just to get us started, When did QM and the various quantum theories catch your philosophical interest to the point that you've been concertedly writing and thinking about it a lot more lately?
It's quite a series of topics. The first one is my philosophical obsession. I've written about it repeatedly and so on. And Sean, this is already to provoke you, interrupt me at any point, is what absolutely fascinates me in quantum physics is, again, maybe it's already wrong, I will say, this idea of, to put it in philosophical terms, ontological incompleteness. For example, the point is not we cannot measure at the same time position and movement. That's for me not radical enough. It still means a particle has a measure and the position, we just can't, movement and position, we just can't measure it. But what if in more radical reading, reality is in itself ontologically incomplete? The point is not that if you analyze reality to the end, you will get a complete description with everything at its place and so on and so on. And as far as I can see, now you will ask me, how does this link with my philosophy? Because it's a very unorthodox reading. In my reading, even of Hegel, the result is not you get the whole truth. The final result is that what you thought was just an epistemological obstacle, like we cannot get it all, just one aspect of the other. The final result is when you realize that what appeared to you as a limitation of your knowledge defines already the reality itself. Reality is in itself incomplete. Now I follow debates and I know the problems with this. If she known in the United States, she being Sabine Hossenfelder, the German one, her idea, as I'm sure you know 1,000 times better than me, is super determinism. And basically, her idea is, if I follow it correctly, on Einstein's line. Hidden variables and so on, we just don't know it all. Where I see an interesting point that she makes is, and now comes, Sean, my first question to you. Some physicists, quantum, with whom I spoke, not as highly graded as you, insisted that all this focus on not the agent, what triggers the so-called collapse of the wave function, that is a secondary unimportant problem. That you can even, this is the radical tendency, if I got it correctly, that you can define collapse even in an objective way. What comes to my mind are so-called decoherence theories. Or another version is quantity, that as soon as the object is no longer at this subparticle level, but becomes part of our reality, automatically decoherence happens. Now, this brings me to another point. I hope we will have time later to approach it, which is time and space. Do you agree? Because I was informed that this is also one of your topics. Is it true or not that this hidden variables Einstein view is more focused on space as a more primary dimension? Didn't Einstein even at some point propose the theory that what we perceive as time movement, is really just moving along a certain spatial line and so on? On the other hand, there are many others, and for obvious reasons it's closer to me, who claim that time is more radical primordial. But let's begin with this, with what I told you. All this problem, and I know...
I think so, yeah.
Collapse of wave function, observer, registration, when does it happen? Because I find all different versions, up to the cosmological one that it's God himself who is the ultimate observer, no reality without God, and to this more modest version, whatever. Okay, teach me where I'm totally losing my mind and tell me at least the state of the things today.
I think this is very good because the time and space questions that you're raising are very, very good, but they come later. So the quantum mechanics, collapse of the wave function questions come first. And to me, it's extremely embarrassing, but true, that physicists don't know what to think about exactly the questions that you are raising. So let me just quickly run through some of the options, because there are sensible people who believe all of them. The fundamental fact that we're trying to accommodate ourselves to is that we have a way of describing the world that is super duper successful with what we call a wave function, a quantum state, the Schrodinger equation, all this mathematical apparatus. But then when we look at it, when we measure it, when we perceive it or experience it, we don't see that wave function. We see a position or a momentum, some observable quantity.
Which is part of our ordinary reality, what we see always.
Well, yes, I don't want to prejudice by deciding what's ordinary reality yet, but we see things. And the things we see, I think what you're getting at is they do remind us of what we thought the universe was back in the days of classical mechanics. Newton would have said that there is a position, there is a velocity. Now we say, well, we observe those, but that's not how we discuss what's really going on. So I can quickly run through at least three options that are very much on the table. There is a very conservative way of going where you say there really are positions and velocities. Those are real things. And there is also something called the wave function, and it's a whole big complicated mess. And that is the hidden variables approach that, like you say, Einstein would have liked. There are still people who follow that, mostly in the context of what is called Bohmian mechanics. You have both the wave function and particles.
That's what I wanted to say. How does these pilot waves, isn't this still, there are the substantial entity are particles or whatever, and you just accompany them as a kind of aura with wave function, no?
I have to be honest, I'm not sympathetic to this point of view.
But
I have trouble
not as
defending
a scientist. For purely philosophical reasons, I'm not sympathetic. But let me now directly move to the third degree. But my KGB file on you tells me that you are sympathetic to many worlds. Reading.
That's going to be the third of the three options I give you. I've given you one.
Sorry, go on. Yes, sorry.
Yes. One is hidden variables, just like you said. The second is more or less what you were pointing to yourself at the beginning there, which is the most radical one, which is essentially to deny the existence of reality, or at least to deny the existence of something that is mathematically precise and that pre-exists our observations. To make this incredibly radical move that says that we can calculate the probability of what our observations will be, and we can then make them, and when we see them, they're real, but there was no such thing as what they were before we observed them. There was only this instrumentalist kind of calculation. And weirdly, even though that is clearly the most radical and hard to really wrap your brain around, that's the one that came first. That's the more or less what Niels Bohr and Werner Heisenberg would have advocated, a completely epistemic instrumental approach to thinking about quantum mechanics. Yeah. Whereas the third option I will give you is a happy medium where you say there's the wave function and that's it. There is nothing else. And the wave function does not collapse and there are no extra variables. And the Schrodinger equation, which tells you how the wave function evolves, is always true, just like Newton's laws were always true in classical mechanics. And the crucially important thing to make that viable is because when we look at things, like I said, we don't see the wave function. So if it's what is real, why don't we see it? And the answer is that we have a wave function ourselves, and we have superpositions of who we are, and they all exist. But the we that does the observing and the experiencing is only a tiny, tiny fraction of what is going on in the whole wave function. So we call this many worlds. And it is, on the one hand, the most simple and straightforward working version of quantum mechanics. On the other hand, it makes you a little bit dizzy to think that all of these different worlds are coming into being. And I would put superdeterminism and Sabina's theories, which come from other people also, as a fourth category, which is even wackier than the ones that I've told you about. But we can talk about them if you want.
Yeah. Thanks very much. This is so helpful. Okay. My first, sorry to go on in this police style, my problem is the standard reproach that I hear and read about many worlds is that one cannot even imagine how to test it with today's knowledge. That it's just an empty hypothesis. It resolves such many paradoxes, blah, blah. But with today's knowledge, we cannot get a clear test.
Good.
This
so that's
approach
wrong.
was already made decades ago.
But you do hear it a lot.
Yeah. Please go on.
So
I'm
it
sorry.
depends on what you mean by test, and we have to get very carefully into the philosophy of science here, right? For two reasons. If what you mean by test is just the very naive falsifiability kind of idea that Karl Popper would have put forward, right? Can you rule out the theory by doing some experiment? Then the answer is clearly and straightforwardly yes, because the theory just says that there is a wave function and all it ever does is obey this particular equation. So if you ever see the wave function not obeying that equation, you have ruled out the theory, you have falsified it. And there are, I didn't mention, but there are other versions of quantum mechanics that predict exactly that in a very quantitative and testable way. So far, what we call the objective collapse of the wave function has not been observed in experiment, but as soon as we do observe it, if that ever happens, we will rule out many worlds.
Uh-huh. No, sorry to interrupt you, but when you say has not been observed, so you don't buy this simplistic materialist, I also don't buy it, version, which says that no problem, collapse happens all the time in reality and so on, and you try to define registration or decoherence in a totally objective way. You don't buy this.
Well, I am super duper materialist, but I think that the only thing the wave function ever does is obey the Schrödinger equation. It does not collapse all by itself. So the alternatives, there's sort of sub-degrees within this materialist, physicalist camp. People like me think it's the Schrödinger equation from start to finish, and what we perceive as collapses are only apparent because we're not seeing the whole story. There are other people like Roger Penrose or others who think that the wave function violates the Schrödinger equation by suddenly collapsing on itself. I think it's very, very difficult to actually define a theory that works along those lines, but it does have the nice quality that it's very, very testable, and it's very, very different in its predictions from what many worlds is.
Okay,
there's the other...
I'm sorry, please. I will discipline myself. Finish, please.
There's the other, even more subtle philosophy of science question, which is, okay, but what about many worlds versus the Copenhagen interpretation or Bohmian mechanics or something like that? And these are all very tricky, worthwhile asking questions. My answer is the following. The problem with Copenhagen versus many worlds is that Copenhagen is not a theory. It is not precise. It does not tell you when wave functions collapse, what a measurement is, what qualifies as a measuring apparatus. It's not that I can't test it. It just doesn't even tell me what the predictions are or what the ontology is. So if you're comparing many worlds to Copenhagen, it's not a fair fight because one theory is well-defined and the other one isn't. It is true that as far as I know, they have no difference in terms of experimental predictions, but they have huge differences in terms of being well-defined. Whereas with pilot wave theories, Bohmian mechanics, hidden variable theories, those are well-defined. I would like to be able to distinguish many worlds from them. I have a deep suspicion that they are experimentally distinguishable, but nobody has actually pinpointed what that difference is. So that is, to me, an open question. I think that there's a lot of Bohmians who think that their predictions are exactly the same as many worlds. I suspect they've not just been trying hard enough.
Okay, now I will try to be more precise. I agree with you. Isn't even one of about Niels Bohr? There is even one very vicious, but I like vicious formulations, point that it repeats almost that the basic formula of Copenhagen interpretation is don't think, just calculate. Don't even ask these questions. Okay, let me go step by step. My problem with many worlds is that the way you put it, I would love this. Only wave oscillations, collapse is something that appears blah, blah, blah. But isn't in some sense, although when I say in some sense, I don't mean it in a precise scientific sense, but it seems to me that many words interpretation simply multiplies realities. We lose a special, everything is true, in the sense of all possible variations are true. So and in some sense, what fascinates me, the ontological incompleteness, again disappears. Everything is fully there. The problem is our limited standpoint. Am I missing something here?
Yeah, so I'm happy about this one because you are missing something, and I can help
that's
a little
where
bit.
I like you. Yeah.
So, two points worth making. One is that it is certainly not true that within many worlds, every possibility exists. It's very easy to point to possible worlds that don't come into existence. What many worlds says, after all, is that we obey the Schrödinger equation. And that implies a lot. For example, electric charge is conserved. I can imagine a world where a proton spontaneously turns into an electron. There is no such world in the many worlds interpretation of quantum mechanics. There are many, many imaginable worlds that just don't come to be. The second issue, which is much more subtle and worth, you're allowed to disagree with many worlds on this one, is many worlds not only says here's the bunch of worlds, it says that the worlds don't count equally. That there is a weight or a thickness to them, and that helps explain why in quantum mechanics you predict there's a probability for X or a probability for Y, but the probability for X is 99% and the probability for Y is 1%. And that's a crucially important part of many worlds that you don't necessarily get if you're just thinking about David Lewis and possible worlds or something like that, right? Many worlds quantifies how big the worlds are, and that's crucially important.
But now I would like my police instinct again comes into action. When you say how big worlds are, is this a ontological category in the sense that some worlds are, sorry to use this term, you can explode, in some sense more substantially real than others? Or can you specify a little bit more this idea of more and less, whichever way you name it, big or strong worlds?
Well, and I do say the following thing often, and it always makes me feel bad, but this is something where if we write down the equations, it's crystal clear. In words, it's hard. But the answer is that it's not that one world is more real than another. They're both real. Let's take the 99% versus 1% example. They're both real, but the way it works out is if you don't know the outcome of the experiment, so you do the experiment, you make the observation, and you haven't looked yet. So maybe you're in the 99% world, maybe you're in the 1% world, right? The impact of this calculation, which is completely quantitative, is that you should assign a credence of 0.99 to being in the 99% world and a credence of 0.01 to being in the 1% world. So they're both real, but you're not equally likely to find yourself in them.
What I still don't get, and sorry, although I'm totally opposed, like you, to that hidden variables in the sense of there is one single substantial reality, what I still don't get here is, okay, Schrödinger equation said 99% blah blah. Then I agree with you, because of our limited standpoint, something happens. Why insist that parallel, or I don't like the word parallel, it's too physical, that at the same time another reality exists, alternate? What do you gain by this?
Nobody wants this to be the case. Nobody is insisting that both worlds are there. That is the prediction of the Schrödinger equation. And the question is, you can either accept it, like I think of what Hugh Everett did as more therapeutic. He was a Jacques Lacan of physics. He wasn't writing down new equations. He was just saying, here are the equations, here are their implications, you have to deal with it. Or you can modify the theory. You can do violence to the Schrödinger equation to get rid of the other world if that makes you feel better. And you're welcome to try to do that. That's basically what the hidden variables people are trying to do. They're trying to invent a finger that points to one world and says, here's the one we're actually in. The others are there, but there's only one that we're actually in. That's why David Deutsch, for example, says that hidden variable peoples are just many worlds people in denial, because they know the other worlds are there. They just don't want to live in them.
Hegel formulations, how should I look it up? Because back to the opposite vision, back to Niels Bohr. I was surprised at how, at some level, he is ultra common sense realist. Doesn't he repeatedly say, all that we can observe, all that exists out there is our common reality. Everything that we measure, it shows on a screen with measuring apparatus in our common reality. So he insists that all these wave function formulas and so on, they have no ontological status in the sense that we have to presuppose another type of reality. He insists that it simply, and here he escapes, I think, too easily into some kind of naive epistemologism. He says these are just our mathematical means formulas, or sometimes he even says language symbolic fictions to account for how did we come from A to B. But both A and B are firmly here. So does he ever try to make a step further? And no, I will be very precise here. I'm laughing, but not substantially, because what would then in this view prove, I of course follow this with fascination, these years, you remember the three guys, the old French one, Alain Aspect, and the Zeilinger, an Austrian man, and the third one is American, I think, or whatever. No. What did they really prove? Isn't nonetheless in what they say a little bit more realist tendency, that in some sense there must be a level of reality which reality, whatever you call it, out there, that works in a different way from our ordinary reality. Another thing, usually what they did is, with these experiments, is usually read as Bohr's victory against Einstein. But isn't it more complex? Because they didn't prove that there is pure contingency. No, they only proved that if you go to particle A, this, then the correlated particle B, down, up. But this only means that there is no link at the level of speed of light or lower. There still can be a link at a higher level. Higher, okay. Outside, no?
Exactly. That's exactly right. Bohr has his, I don't read a lot of Niels Bohr. He's famously hard to understand, but he has his modern avatars, right? There are people alive right now who very much think that reality does not pre-exist our measurement outcomes. And as you imply, Einstein, as well as Schrödinger for that matter, were very much on the other side. They were very much physicalists, materialists. They wanted to see the mechanisms behind what was going on before we made our observations. The problem that they had, as you're pointing to, is that they had Einstein invented relativity. He thought that space-time was very fundamental and the speed of light was absolute. So what he pointed out in the famous EPR paper, Einstein, Podolsky, and Rosen...
Oh my God, that's even I know that one.
Yeah. But maybe the audience doesn't, so I'm trying to be careful. Quantum mechanics seems, he said, to be incomplete with any kind of underlying theory that would take locality seriously. The idea that not only is there space and time, but things that exist have locations in space and time, and things that interact do so at the same point of space and time. And Einstein says quantum mechanics seems to be incompatible with that. And John Bell proved a theorem saying, yes, it truly is incompatible with that. And then the people who measured their correlated photons, their entangled photons, Aspe, Clauser, and Zeilinger, verified that Bell was correct, that you cannot reproduce the predictions that we observe in the real world with any naively, locally realist theory.
But only locally. Only locally. It must be local.
Only locally, exactly. So amusingly, even the Nobel Committee got this wrong in their press release. They said that these experiments ruled out hidden variable theories, but that's just false. They ruled out
I'm
local
so glad that you say this, because that was my first reaction. Sorry, it doesn't rule out all hidden variables, just those operating locally.
In fact, just to make the story more amusing, John Bell was motivated by the fact that David Bohm had written down a non-local hidden variable theory that was very successful. And Bell really liked Bohm's theory, and he asked himself, Bohm's theory is clearly manifestly non-local. Is that a necessary quality, or can we get rid of it? And what you proved is you cannot get rid of it. It's necessary if you want to match the data.
Again, here, first, let me return for a brief moment to Niels Bohr. I hope we are both here on the materialist side, in the sense that what I worry is not so much this direct New Age spiritual reappropriation if I were to be a ruler of a Stalinist empire. If you say, as I read somewhere, some Indian idiot, not Native American, India, said, oh, but all that Zeilinger and those guys proved is what we Indians know from Upanishad, from Bhagavad, all that bullshit. Even the movie, I haven't seen it, but it didn't prevent me to write a review of it. Oppenheimer goes into this, all those quoting Bhagavad Gita, I am the destroyer of the world, whatever. So even Bohr was not clear here. When he what's his principle? No, sorry, I'm so confused now. Of complementarity, yeah. He had this tendency to falsely universalize it in a pseudo-spiritualist way. For example, he said, it's not just particles. It's also, he said, to the Bible, then wisdom versus knowledge and all that bullshit and so on. So this is where we materialists, intellectual police, no? We need some agency to say, the moment you mention this, do you know what I give you here? One-way ticket, first class to Bullock for 10 years. No, but seriously, isn't this, that's why quantum physics interests me. precisely because it breaks the confines of our ordinary notion of reality, it is always exposed to this pseudo-spiritualist danger. So my problem here is, I read this and I learn also from people like you that golden era of Copenhagen, shut up, don't think, calculate, is over. We are returning to what traditionally is called ontological, metaphysical questions. My temptation is, and please tell me from what you know, am I totally wrong or not? What fascinates me in this Bell's theorem, no? What if this element of maybe even contingency is not the right term? Just this openness, not full determinism, and so on. Are we back with many worlds in determinism, or is this openness of the universe maintained? It's a wonderful idea for me that, even if you look at details, no, it's not. You discover deep, at some point, reality is blank open. I would like, as a philosopher, for non-scientific interest to save this. Hit me. With counter.
I think that two things. Your characterization of Bohr is right on. Not only was his philosophy of quantum mechanics a little bit fuzzy, with not defining what he meant by measurement and whatever, but he did, unabashedly connect it to ideas from ancient Eastern wisdom and complementarity.
And what you find only Kant in him, even Eastern wisdom. He was already in that.
Yeah.
Oh my God,
he was.
A lot
and
of
not
work
to anyone's
for
benefit.
Our police when we take power.
Right.
Oh my
God.
God.
The determinism question is a much trickier one, because then, just so everyone knows in the background here, so, quantum mechanics came on the scene in the 1920s and 30s with the Copenhagen interpretation and whatever. It was in the 1950s that people like Bohm and Everett finally wrote down 100% physical material versions of quantum mechanics that fit the data completely well. The physics community could not care less. They just ignored it. They go on.
Yeah.
If you care about this, you're not going to get a job. You'll be kicked out of the field. But we
wasn't
know
the
you
problem
can't now say.
Bohm also a political one. He was very left-leaning.
That's right. He was kicked out of the country, not only of the field.
Right.
Everett left the field by himself, but he was kicked out of the country for different reasons.
Yeah,
not because of quantum mechanics.
No, because of his politics. Yeah.
But so there are still people today who will argue in favor of idealism on the basis of quantum mechanics.
Isn't
that we have to put consciousness
approaching that?
Sorry,
a little bit. Roger Penrose approaching that a little bit?
Maybe a little bit, but at least, yeah. But I think, there are some people who will simply deny the existence of objective reality and put mind and agents at the center of everything.
That's what.
And look,
yeah.
Maybe that's right, maybe it's wrong. But my point is, quantum mechanics doesn't force you in that direction. There's perfectly mechanistic versions that fit the data perfectly well.
But so again, your answer to this mega reproach from Einsteinians, Sabine Hosenfelder, and so on, that quantum mechanics describes, it's very simple reproach, I just repeat it for the viewers, describes a certain universe which is in itself consistent, wave function, blah, blah, but it cannot account in its own terms of our ordinary reality measuring and so on and so on. If I read you correctly, many worlds does this in some sense.
Yes. Yeah, exactly. So I think, I forgot you also mentioned determinism, which is a crucial point here, which again, physicists don't agree on. So for both hidden variable theories, Bohm, tidal waves, etc., and for many worlds, you're in a situation where the underlying equations and dynamics are 100% deterministic. Laplace would have been happy. Laplace's demon could predict everything that happens. But in both theories, there is some epistemic uncertainty. There is some subjective probability that comes in. In the case of hidden variables, it's because you don't know where the hidden variables are. In the case of many worlds, it's because all of these different branches exist and you don't know which branch you are on. So there's the appearance of indeterminism because you cannot, even if you know the wave function of the universe perfectly, you still can't predict the outcomes of your next experiment. So it's a weird in-between ground.
You know what I would like to do? Now, this is a pure abstract, in a bad sense, philosopher speaking through me now. I would just like to elevate into, as you may have guessed, into, how should I put it naively, ontological status, to put into reality itself this element of uncertainty. Can't we say, while keeping Schrödinger equation and so on, that, and that's for me the mega greatness of quantum physics, that there is an element of uncertainty which is not just epistemological, but which is in itself. Isn't this also implied in what you said, 99%, 1%? It's not just that we don't know. It's in reality itself in some sense, because it's 99%, 1%, and so on. You don't like this idea?
I am honestly, I know that you told me to just say the truth and not say that I'm not sure about my opinions being true or false. But this is a good area where it's okay to be a little uncertain. I would say that in the many worlds point of view, we're faced with a weird metaphysical, a novel, unique metaphysical challenge. Because, like I said, we can know everything about the universe and still not make a prediction. And the reason why is because that 99% world and the 1% world are both going to become true. And there will be a future version of me in each of those worlds. And there's no unique, it's not even sensible to ask which one of them am I going to be. They're both going to be in existence. They're both going to have all of my memories, right? This is utterly unprecedented in physics or philosophy. So I claim that the way to distinguish it is to say that both of those future selves are real people, but they're in positions of self-locating uncertainty, indexical uncertainty. There's something they don't know, which is where they are in the universe, which branch of the wave function they're on. And it's perfectly deterministic underlying dynamics, but a new situation in which there's no univalent you that can ask questions about the universe. There's many different future versions of you.
This, nonetheless, reminds me of problems that emerged even with Descartes' cogito in modern philosophy, where here I see the actuality of Descartes. Yes, universe is mechanistic and so on, but I cannot locate myself into it deterministically. This is the big enigma, I think, in some sense, of the entire modern philosophy. And I still...
Well, I recently did a podcast with Robinson, with David Albert, who is another very well-accomplished philosopher of science. And we talked about the fact that there is an analogous situation that also comes up with the multiverse. Not the many worlds of quantum mechanics, but the cosmological multiverse, where we imagine that just very, very far away, there's many different observers and so forth. And philosophy is just not currently up to the task of dealing with this, I think. I mean, it can be and should be.
Yeah.
It needs to get better. But how do you evaluate questions like, what would a typical observer see in this ensemble? And should I care about that question because I am not a typical observer? Should I reason as if I were typical? Cosmologists, bless their hearts, they think the right thing to do is to reason as if they were a typical observer in the universe, even though they know perfectly well that they're not. So they go through this weird thing where they say, okay, I'm going to forget everything I know about my actual situation. I'm going to pretend I was a typical observer. I'm going to make predictions. I'm going to open my eyes and go, oh, this is very surprising. But that we can do better than that, and we don't do yet.
But you see, now we don't have time to go into it, but this is another metaphysical topic that fascinates me. Why? And often, for me, deterministic philosophers get caught into this. You want to be as realist as possible, but to formulate your position, you have to posit an impossible point of subjectivity, where you see no universal observer, and so on and so on. What tempts me, but I don't have, of course, not a scientific formula here, is, but okay, let's return to many worlds. But you think that, but doesn't Schrödinger equation just give probabilities from what will happen now? Like 99% this happens, okay, everything happens. I got your point.
Yeah.
So,
not everything happens, but some things happen, and some things happen more than others. So, I think that this is the challenge, because if you're a many worlds person, you do think that the Schrödinger equation is all there is. And let me back up just a second to make it even a little bit more reasonable. If you believe in quantum mechanics at all, and you want to be realist at all, right? So then you will have to say that the electron that can be spinning clockwise or spinning counterclockwise, quantum mechanics says it could be in a superposition, right? It truly is some combination of spinning clockwise and spinning counterclockwise. And so if you believe that that can be physically true, not just a state of our knowledge or prediction, then you should be able to believe that the whole universe can be in a superposition of many different possibilities. So you're not asking for anything more by becoming a many worlds person. All the possibilities were always there in the formalism of quantum mechanics. All of the new challenges are philosophical. How do I deal with the fact that there are many people like me with exactly the same epistemic states? How do I make predictions of what they're going to see when they open their eyes and things like that? It is a radically different view of the world. Maybe not as radical as the view that says that there is no reality, but still pretty darn radical. And I think the quantum mechanics forces us to be radical one way or another.
I see. Okay, let me move it, connect. You know what fascinates me? Now I move into my own speculations about philosophy, language, and so on. I like so much the notion of superposition, because I think, I will try to put it in very simple terms, but it's a more complex theory. A guy who teaches, French guy who I think, what is he, Stanford or Santa Cruz? Did you hear the name Jean-Pierre Dupuy? D-U-P-U-Y, a French theorist.
Vaguely familiar, but not an expert yet.
Who tried to introduce, but without any bluffing about quantum physics, the notion of superposition into historical processes and knowledges. I will give you an extremely simplified example. Let's say today we are in an, I will go even specifically, Russia-Putin, Ukraine war. Again, maybe it's already decided in the terms of the Schrödinger equation 99%, but we don't know what, that there will be global war or not. But his idea is this one. And again, this is pure speculation more pertaining to human language, is that in our human universe, I'm here often maybe you've heard to that famous quote from T.S. Eliot, who was an idealist, a conservative, but nonetheless, he put it nicely that every new invention, really new in art, in some sense also changes the entire past. It makes it readable in a different way. So Dupuy's interpretation against these lines would be, let's say that in 2-3 years, there will be World War III. Then automatically, we will retroactively read as. It was clear all the time that this should happen. We just had illusions that we can avoid it. Let's say that World War III will not happen, then we will act the way we read today the Cold War. No? Yes, it was danger, but somehow we avoided it, and so on and so on. But Dupuy's point that I like is that it's not enough to say that these were just different possibilities, options. No, it's a stronger term. It's in the sense that if something happens, of course, it doesn't restructure the past in its brutal reality. But the whole symbolic constellation of how we read the past changed. And this now, I could go on here for hours. I love these examples. That's why I am not, and I think in my crazy way, I got this lesson from quantum physics, mechanics, but I am not, I totally reject this stupid historicist view. To understand Shakespeare, you must study in detail Elizabethan era and so on. I would say first the opposite. To understand Elizabethan era, read Shakespeare. You will learn more. But more seriously, for me, really great works of art are precisely the ones which cannot be limited to a specific historical constellation. Every new epoch reinvents them. For example, with Shakespeare, many people don't know, but immediately after his death, it was the horrible era of Racine and all those French guys, classicists, and Shakespeare was considered vulgar. Only through Romanticism, Shakespeare was reinvented. And I love these paradoxes, how sometimes precisely not knowing all the context of Shakespeare, historical, you can propose a reading which is much more convincing. And it's not simply an external reading. Again, I'm back to my point about openness. It is as if, which is obvious, Shakespeare didn't really know what he is doing. Which is here my wonderful example. That it's attributed to Lincoln, but I read somewhere that he was not really the first to say that, you can cheat some of the people all the time, all the people sometime, but you cannot cheat all the people all of the time. This is a deeply ambiguous statement. It can mean there are some idiots who can be treated all the time, some the same, or it can mean in one situation, I will be the idiot, in another situation, you or you. You see, this is for me how language is structured. It is open. The author himself is not a possessor of some hidden meaning. That's why my favorite example is, where Shakespeare. For me, the best cinema version of Shakespeare, Hamlet, is Kurosawa in 1962 in Japan, did a version of Hamlet with a wonderful title, Only Evil People Sleep Good, which is a deep truth, Real evil people don't care. They're not haunted by God. And again, it's set in modern Japan. Hamlet is a student, returns to Tokyo from United. But what I'm saying is, you see what I'm aiming at. I'll give you another classical example. I remember from Dupuy this quote. You are too young, some 20, 30 years ago, there was a presidential candidate in France, Edouard Balladur, who failed. But when there were some pre-elections in Le Monde, there was a wonderful comment saying, if Balladur will win next election, his victory will be necessary. The paradox. After something happens, it becomes retroactively necessary. And now you see where I am aiming at. I'm desperately looking, but you almost converted me. I will have to work more in quantum physics for some kind of ontological foundation of this openness. That
good.
I like this idea of retroactive determinism. And I will give you the ultimate social proof. This is not physics at all, but I love it. Protestantism. People don't notice this obvious paradox. Weber, Protestant ethics, origin of capitalism, blah, blah. But since, if anything, capitalism is a system which pushes you to constant effort and so on. Isn't it strange that you would have then expected that Protestantism would have been against, and this brings me back to your point in a very nice way, that capitalism would have been against predetermination. Because if everything is predetermined, why not I sit at home, masturbate, and watch Pornhub or whatever? It's already decided. But precisely capitalism, which is the most active system, needs predestination. Along what lines? Along what you said. Here I come back to you. Here I will use you. When you said wonderfully, yes, Schrödinger equation objectively valid, but with one small point. I don't know where I am in it. And that's Protestantism in religion. You see now what I am aiming at, you know. But nonetheless, you know, let's go to the end in metaphysics. I see your point, but then what would be your answer to where does then our limitation? Now I'm going back to you. There is an objective description. We can give it. We just don't know where we are. You don't think that how can many worlds interpretation account for this uniqueness of us? Not uniqueness in any metaphysical sense, but how we are one, unique, but still can arrive at this objective, as it were, view of this.
Good.
Is something.
So let me say two things. One is a
how
little
do you
bit.
account for the subject itself? Himself, herself. I will not go into this bullshit now.
So I'm happy we can solve these questions so easily in this podcast. It'll be very, very valuable to future generations. I'll say two things, one a little bit negative and one more constructive. The negative thing is I am reluctant to think about quantum mechanics when I think about the uncertainty of human history, because there is a difference between quantum mechanics and probability or stochasticness, right? There's plenty of room for unpredictability in the world in addition to what quantum mechanics gives us. What's special about quantum mechanics is that there's not just the probability. The probability is derived from this thing called the wave function, which distinguishes the idea that there's two possibilities, but we don't know which one is true, from the idea that there's really both possibilities at once. And I think that, at least when it comes to human subjectivity in history, you don't need to imagine that all the possibilities are simultaneously physically true. You can just work with the fact that there's so much uncertainty and, unpredictability in the real world that we need a language of probability and computation and information to really make progress on these things. And it might involve the past in an intricate way. In fact, I'll mention two funny things. One is, I recently did a podcast with Katie Elliott, who's a philosopher, and she made very much a similar point that you're making about Protestantism. We were talking about predestination and eternalism, and she said that she can make she convinced herself that Calvinism was okay.
I know, but that's the latest theory. It's no longer Luther. It's Calvinism, which is elevated.
Calvinism, right.
Yeah.
You know, the problem with Calvinism is, you're either blessed and going to go to heaven or you're not.
But you never know.
But
you never know.
But you never know. So the worry, she points out, is very well known, is that, well, I can just act bad because I'm predestined to go to heaven or not. But what you don't understand is that God knows that you're going to act bad. And so if you act bad, you're bringing to reality the possibility that you're not going to go to heaven. So even though it is predestined, because you don't know, it is still in your best interest to act good.
Yeah. No.
That will align you.
I forgot his name. My God, I forgot his name. And Protestant, okay, Baptist, whatever, theorist, theologist, who is also known as the one who uses analytic philosophy. And he he precisely in the terms of beyond the speed of light, he defended Protestantism because he said exactly what you said now, that like if I'm predestined, how why should I act good and so on? But again, God is beyond time. God knows how you will decide.
Exactly.
No, that's why
it's like Newcomb's paradox. That's how we got into it. Yes, it's if you believe that there are oracles that know about the future, you will behave differently than if you don't.
Yeah, but
again, anyway, the other thing I wanted to say, I wrote a short essay that I published on my blog years ago called, I hope you'll be amused by this, "The Universe is Structured Like a Language."
So somehow for me, universe, not unconscious, but universe.
Not the unconscious. The universe is structured like a language. So I quote you and I quote some quantum physicists. And the basic idea is that the universe evolves from very orderly, low entropy early state to very disorderly, messy future state. Along the way, complex structures appear. Right? This is the kind of thing that at the Santa Fe Institute we're very interested in understanding. And the implication is that somewhere there in the laws of physics, in the laws of dynamics, in the way that we think about how the universe marches forward, there exists the potentiality for interesting, complex things to happen. And even though they were not sort of embedded intrinsically in the initial conditions, they came to be because of the structure of the dynamics along the way. And maybe quantum mechanics does play a role in that. This is all stuff that nobody claims to understand very, very well. But if there's something computational or useful about complex structures coming into existence, then that would be very nice to understand. And by the way, by complex structures, I include you and me, right? Why did living beings come into existence, even though the second law of thermodynamics says that the universe just rolls down to more and more disorder? And the suggested answer is that the way that you get to more and more disorder is to pass through intricate, complicated things. And you can't predict very well which one they're going to be.
Can I now bombard you with my last big metaphysical point? Since I was told and you indicated you also do cosmology and so on. Okay, to cut it short directly to the thing. Is Big Bang Theory out or not? Because I hear again and again that you find traces of something that must have gone off before Big Bang and so on, all that stuff. So the idea is almost a kind of a Stalinist dialectical materialist vision of, repeated Big Bang here, collapses here, explodes there. Where do you stand here?
So the sad thing is that the phrase, the Big Bang Theory, refers to two very different ideas at the same time. One is the whole history of the universe from t equals 0 to today, where it started hot and dense and it rapidly expanded and galaxies and stars coalesced out of it. And the whole bit, the universe is approximately 14 billion years old, all of that. That story is just 100% solid. It's not going away. There was just this week excitement on Twitter because someone claimed it was completely wrong, but they were themselves completely wrong. What can I tell you? There's so much evidence in favor of this general picture, 14 billion years, etc., that we don't need to worry about that being overturned by future experiments.
Yeah, but nobody wants to do this. They just claim that there must have been something, other Big Bangs before. They don't say there is no Big Bang.
Well, sadly, no, there are people who still think that even the story I just told you is wrong. Then they're sadly misguided people. I'm just letting you know. That you can find some crazy claims that the universe is 30 billion years old or infinitely older. There's still people out there who say those things. 6,000 also last Thursday. Yeah, these are all on the table. But now the harder question is that sometimes we use the phrase the Big Bang to refer to just the moment t equals 0, right? Just the first moment. Forget about what happened after that, but the actual
loss
event.
Of nature were not. Yeah.
That's right. Now the only honest thing we can say is we have no idea what happened. Physics is not up to the task of saying whether there was truly a singularity, whether that was truly the beginning of the universe, whether it was a bounce or a quantum nucleation event. All the options are on the table. I'm responsible for some of the options. There's a picture. This picture right here is one of my favorite theories, where the universe is infinitely old. So I think that the idea that the Big Bang that we talk about is not the beginning is absolutely viable, but we have no way of knowing whether it's true or not right now.
Now, can I... so you don't agree with those? I read some reports on it that if we analyze these early stages, Big Bang, blah, blah, we can find in it immanently traces of something that must have happened before. You don't think this is necessary?
I don't think so. I know that people have pursued that possibility, and Penrose is one of them. And I'm very, very glad they are pursuing the possibility. But I think that the data so far, as well as the theoretical predictions, are that anything interesting gets wiped out in the interim. In that period since the Big Bang, everything was just smooth and featureless. I would love to be wrong about that, and I hope I am, but I wouldn't buy any existing claims along those lines.
But another thing that bothers me, it is that I hope we are here on the same materialist side. You must have known, everybody quotes it, a dialogue. I even don't know, did it really happen or not? Stephen Hawking was at some conference with the Pope, and Pope, the Polish reactionary guy, told him, "Here we have no misunderstanding, Mr. Scientist. Your topic is Big Bang and after, our topic is before, you know." I don't buy
I do know the story, yes.
I think this, to search within the space of science for an opening where somehow religion or another dimension enters, I hope we agree, this is absolutely a wrong perspective. These desperate attempts, you know, to
completely
thing.
wrong. I mean, I don't think that religion is very informative for anything interesting. I think that it's plays a hugely important historic and cultural role that I respect very much. But when I want to think about why the universe exists or where it came from, I'm going to think about science and philosophy. I'm not going to think about religion. In fact, I think that your Hawking story is true, and it's a reflection. There was a previous story.
Well, I didn't know.
A lot of the development in early days in the 30s and 40s of the Big Bang model was by Georges Lemaitre, who was a Belgian priest. And the Pope put him on some commission to, science and religion. And the Pope at the time, who I think was pious, said, well, this Big Bang theory is great. It proves that Genesis was right. It proves that the universe had a beginning. And Lemaitre said, no. Do not say that. Because if you start saying, well, we've proven religion right by science, tomorrow science is going to change its mind. And you don't want to say, oh, we were wrong about religion.
You know, this may interest you. I almost admire, but I despise them. Don't be afraid. Some fundamentalists, I had along these lines a very interesting debate some time ago with a Catholic friend who was at least honest. You remember that mystery of the Turin shroud, you know, are those stains there Christ's blood? And you know what confidentially this highly placed bishop told me? He prays to God every evening that this is not really Christ's blood. You know what? How he reasoned. If this is somehow we prove it, don't ask me how, Christ's blood, then the first question is, let's analyze DNA. And what we will get there, probably now I'm extremely brutal, that Christ was the result of Virgin Mary screwing with some servant there. But it's better not to know. But some American fundamentalists have a crazy answer. God doesn't have a DNA, so we will just get the double DNA of Virgin Mary herself, you know. So this is for me the most dangerous temptation. This naive fundamentalists, which even lack this, what I find in authentic religion is this radical openness. For example, great guys, the one who was loved by Niels Bohr Kierkegaard. He said, I'm not sure that I believe. I only maybe believe that I believe. And I think the moment you go into fundamentalism, you are lost. You are lost in the sense that you... But the final point. You know why I like so much this quantum physics against this Einsteinian view? Because it's usually, and I think they're idiots, I hope we will agree here generally, usually people claim Einstein was more a materialist, objective reality and so on, while Bohr opened up the path for all this stuff. But I believe that it's almost the opposite, that Einstein is interesting. You know his famous retort to Niels Bohr, God doesn't play dice, and then he even says that I don't believe in personal God, but there is a the divine dimension in this eternal cosmic order, the beauty of laws of nature, and so on and so on. And we all know, Bohr, here I bow my head to him, gave a perfect answer. Don't tell God what to do. What not to do.
Yes, very
much. What I like here is that I think that if, not in the sense of any fully religious sense, but in a sense of a belief in a firm order of our reality, this is for me the most basic, even today I would call it not theological dimension, but this belief in what in my Lacanian jargon I call the big other. Even if we don't know it, there is a cosmic order and so on. But you know that here I think that quantum mechanics opens up a path to a much more radical materialism. And I put it, maybe you know the story in this way, and I was so glad, narcissistically. 2-3 months ago, I watched on Austrian TV an interview with the Austrian guy, Zeilinger, one of the three, okay. And the interviewer, a lady, asked him, literally mentioning my name, that what about my idea that quantum, this old joke that I like to repeat, you probably know it, that quantum physics demonstrates that God is an imperfect, lazy idiot, you know, that God was too lazy to determine things to the end, and we, as it were, went too far. And he said that there is a long, at least in Europe, a long-standing joke about this, that quantum physics is one big proof that God is lazy. He didn't want to do all the work, you know, and that now, so I think this is my big effort. We are on the same line here, I think. How to read quantum mechanics in a strict materialist way. How to get rid of all this. You know, quantum mechanics means, you know, the whole syllogism is horrible. Quantum mechanics means only observer brings possibilities to reality. A, the universe really exists. B, so there must be a mega observer who is God. But still, let's maybe slowly and every time conclude with some. So I will have to think a lot more, because I'm still bothered, and I will quote you amply, by your final formula, which is this wonderful one of many words interpretation. We can describe the world perfectly, we just don't know where we are in it. My goal, I obviously don't know enough of science, is to somehow, in a totally, not in an idealist way, this means reality has to have an observer, but in a truly materialist way, to somehow find a crack, inconsistency in reality, which is not subject, but which opens up the space for subjectivity. In what sense? Let me conclude before I confuse you. Because we here come at the point of freedom. I read Penrose, who likes to, he's one of those who think that you can ground human freedom in quantum phenomena. But I think that even if you accept radical uncertainty, openness, this is not freedom. Freedom is not, as intelligent people point out all the time, freedom is not contingency. Freedom is a different sort of determinism. I do that because I decided so and so on. So this quick link, and it's very popular among cheap philosophers today. Oh, but doesn't already quantum physics open up the space for freedom? Do you agree? It's wrong. It's total.
I completely agree that is wrong. But I will mention something that I've been thinking about only recently. In fact, maybe in the last hour, you've helped me clarify it. But there is a role for quantum mechanics, literally quantum mechanics, not just metaphorically, in accounting for the richness of the world that we see around us in the following sense. What if classical mechanics were true, right? What if there was no wave function, everything was perfectly deterministic? You could be Laplace's demon, so you could know the complete state of the world today, and that would predict the state of the world in the future and the past. If that's true, then all of the richness around us, including, you and me, Robinson, having this discussion, was inherent in the initial condition of the universe, right?
But now I
just
will
take
play
us today.
Your role before. It depends how you define the word inherent. You can also read
Yes, it does, but I have a definition.
Possibility, blah, blah, not fully deterministic, Sorry, go on.
What I'm imagining is if classical mechanics had been true, then you could take our universe now, you could use the laws of physics to evolve it to the early time, and it would look smooth and, featureless, but only because there were very, very, very subtle correlations there that you could then evolve backward, evolve back forward to the present day. Like, we were implicit, let's put it that way, in the initial conditions of the universe. But when you have quantum mechanics, now that's not true anymore. The early universe can be truly simple and featureless. And what happens is, as these branches happen and decoherence happens, then individual parts of the universe can begin to look complex. And you can't predict exactly where you're going to be, because like we said, there's many different futures and you're going to be in all of them. And there's different versions of you that will be in all of them. But this sort of, the action of quantum mechanics is to start from a simple, beautiful, pristine state and create many, many, many very complicated, very interesting worlds.
Now I will try to strike back with a precise metaphysical question. You said at the beginning, in a much more complex way, but some basic, whatever you call it, simplicity. But wouldn't it, if we were to be able, I'm returning to your idea of this ideal observer, which would have seen the entire picture, all the possibilities, wouldn't that also involve some kind of return to simplicity? I'm not saying that it is a simplistic image. It's very complex. I know all the options and so on. But in a way, it would have been a flat world, like everything is...
Well, I think this is good. This is a very good point, but I think it's the difference between hardware and software, right? An observer like Laplace's demon who could know everything and do all the calculations is a very simple concept, not that complicated. But the data, the software that person would need to actually do the calculation corresponding to our universe would be incredibly complicated. Whereas in quantum mechanics, Stephen Hawking and Jim Hartle wrote it down, the wave function of the universe, and all of the complexity can just come about universe by universe, world by world afterward.
No, I see, yes. Oh my God, there are so many. Okay, sorry, I'm slowly getting tired, but there are so many points here. I now see where I will have to rethink my position. Can you, this precise idea that you mentioned, now you can even, you, the middleman, exclude this or what, but I would love to have do you have a text where you develop that precise point? Many worlds. ideal observer, everything objective, we just don't know where we are. Is there a text by you?
Not yet, but I'm happy to write something down. Like I said, I've just been thinking about it, in the last few weeks.
It's lovely.
So.
I like this idea that this is my dream, that I write text so that somebody will quote them. Yes, it's directly.
It's very, very possible that someone else has written it down already.
The big problem for me.
Yeah. Yeah, I mean, it might be completely unoriginal. That's very possible. So I will look to see if anyone else has already written it, and if not, I will write something down.
What's the trick? That people use different terms. These nightmares happen to me.
They do, I know, yeah.
You don't find it, but another guy with just different terms.
Yeah, I know.
The same thing,
We're all just remixing.
Slavoj, I know it's late for you where you are. Is it okay if I butt in with a couple questions before we finish?
Yeah, but don't expect, I'm here.
I will direct them toward Sean, and you can cut in as you like. But
now, I love this idea. Now, I always make this joke when people ask me, would you like to have a dialogue? I say, yes, I love dialogues, but the way they're written, the late Plato's dialogues, where one guy talks all the time, and the other guy just every 10 minutes says, by Zeus, so it is, Socrates. So I will leave it myself to that. Please ask him. Ask Sean.
Okay, thank you. Yeah, so I haven't read any of Lee Smolin yet, though Einstein's Unfinished Revolution is on my list. But so I've read an article that Slavoj wrote. I think it's upcoming in a book next year on quantum theory. But in it,
it's not a book in quantum theory, just one short chapter. Sorry, yeah?
Yeah, just one chapter. But Slavoj paraphrases Smolin's belief that quantum mechanics is the most successful theory ever formulated, but the only problem with it is that it is wrong. And I have the sense that it is at least incomplete in that it doesn't cohere with relativity. So there's no quantum gravity, no theory of everything.
No, it makes a very standard point here, Smolin.
Right. But what I'm wondering is how you gloss this idea, and more relevant to our discussion is whether the many worlds interpretation is something that's in jeopardy on the road to this theory of everything.
Yeah. There is a temptation in certain circles to, sorry, that's a little too prejudicial. We don't know what the final theory of everything is, right? So each one of us as individual researchers will have our favorite ways of trying to make progress. And this goes back to what we discussed at the very beginning about preferences for different versions of quantum mechanics. Many worlds as a theory is as simple as it is possible for a theory to be. The problem with it is that connecting it to the richness of the world involves some tricky metaphysical and physical steps, right, about which people can be rightfully skeptical. Whereas something like hidden variables or whatever is an ugly, complicated theory, but the world is ugly and complicated, so it matches the world in a more easy way, and you can have different feelings about what to do. There's a third way, which is someone like Lee, who says, like, I don't quite see how it is working right now, therefore I will throw it all out and start from scratch and try to do better. And to me, we're nowhere close to that point yet. We have not yet done anything like trying to understand the world in the quantum language to motivate trying to improve on quantum mechanics. In particular, just to be clear about relativity, there's special relativity and general relativity. Quantum mechanics and special relativity are 100% compatible. That is literally quantum field theory, which is the best tested theory in the universe ever. General relativity, which says that space-time is dynamical and that's what gravity is, it is true. We do not have a once and for all final quantum theory of gravity. But again, to me, many worlds is the most promising route forward for doing that. And if you'll indulge me just for, one more minute here, the reason why I think we are stuck is because even the most highly trained physicist learns classical physics first. Newton's laws, the Kepler's laws, the planets, etc. And then they are taught how to take a classical theory and convert it into a quantum theory, to quantize it, right? And that's what we do with electromagnetism and the standard model of particle physics and all those things. there's no law, rule, or even suggestion that says that the correct quantum theory of the universe has to be obtained by starting with a classical theory and quantizing it. The universe doesn't do that. It just is quantum from the start. And if you want to imagine that maybe that's why it's been difficult to quantize gravity, because you shouldn't be quantizing gravity. You should be thinking about quantum mechanics and finding gravity within it. And clearly, I would argue, I'm not going to bother you with it now, but I would strongly argue the right framework to do that in is exactly many worlds.
But okay, now it came to me, my last, not attack, but problem. You know, I mentioned this, I admit it, very suspicious parallel between many worlds, and you pointed out immediately the difference and this in our symbolic universe superpositions. This may happen, that may happen. But this is my restraint, not that the theory is too crazy. My God, I'm a Hegelian. The more crazy it is, the more we like it. But I have another problem. But this different, for example, 99%, that this happens 1%, okay, and we have both. But though these two, or I don't know how many, infinite universes somehow interact, or it's just totally different lines. This is, as a philosopher, maybe it's a wrong instinct. I would be obsessed with some interaction, you know. Like to say, it's very primitive what I will say. I in advance apologize, but to say, yes, we live in this 99%, but somehow to understand it, you have to read it against the background of the shitty 1%, which that's what I don't find in many worlds. Or I don't know enough about it. How would you react to this?
The short answer is the different worlds will not interact. This is something which Everett, when he first wrote down the ideas in the 1950s, he was not clear on. He didn't have quite the technology that we have, the intellectual technology we have. But this is exactly what decoherence gets you. Since the 70s and 80s, when we understand decoherence better, it's not just that you are allowed to think about different parts of the wave function as separate worlds, but it's literally the right way to think about them. They don't interact. They won't interact going forward because they've decohered from each other. And there's a technical exposition about that involving states in the environment being perpendicular to each other. There's a small footnote there because if you wait really long, if you wait 10 to the 100 years, then all of the worlds will in some sense blur back together into one big world. The youth of our universe is a crucial feature in allowing these different worlds to be separate. But even though Hollywood would like it to be otherwise, in the real world, the separate many world branches are completely non-interacting with each other.
I see. Sorry, it was mentioned to me by our middleman that did you, or am I misreading you, that you kind of read in detail the script of that shitty movie, and this very predicate makes it clear why I don't like it, everything, everywhere, and so on. Because what I didn't like in it is that with all these different versions, at the end it has this shitty conclusion, but this is the real world, we should accept it, and so on. I would like, what is missing for me in the movie is precisely what you pointed out, this, but we don't know where we are, and so on. This uncertainty is lost, I think, in the movie.
You know, no, you're completely right. I didn't read it ahead of time, but I did interview the directors, writers on my podcast. We had a wonderful conversation. They're very smart people, but the demands of narrative are different than the demands of physics is the problem. And not only multiverse movies, but time travel movies have this same feature where even though there's multiple timelines or whatever, the narrative focus implicitly lends more value to certain characters and devalues other characters. And if this were the real world, that would be completely illegitimate, right? Like all the different people in the different timelines, they have a right to exist. You telling me you're going to eliminate my timeline just because it's not yours? You're a genocidal monster. That's terrible.
No, because that's my problem. Now I will go even one step lower. did you see Indiana Jones 5?
I did.
You did? Oh, we are normal people in every day. The moment it's a shitty movie, but for some reasons I found some, for me, it's a very desperate movie. It's clear that Indiana Jones' desire is Archimedes, I want to remain there. And that beat punches him, go back, and it's a very desperate ending. Her function of Phoebe, that actress, is not erotic. It's just to bring the couple back together. And you know how they are. Two desperate old men embracing and so on. Can you even compare this with being in Syracuse at that point and so on? This I find much more productive. The conclusion is not, but this is the real world or whatever.
So, I could not possibly agree more.
I don't like the movie, but I find now, what attracted me to Indiana Jones 5? That it was so universally attacked as total bullshit or whatever. It automatically evokes my sympathy, no?
Well, there's a fundamental conservative teleological aspect to this way of thinking, that our timeline, our universe is the right one, and we should be in it, and we cannot possibly think about improving it by changing the past or anything like that. I think that the filmmakers missed a chance. They should have left Indy, spoiler alert, back there with Archimedes. He would have been happier. He's getting old anyway. They went for a sappy, lowbrow ending.
No, but so at least we can conclude in this way then that in spite of all, from my side, unresolved tensions and so on, you put it wonderfully now. The big lesson of, also in many words, quantum physics is always bear in mind that this is not the only possible world. Don't put this universe as a major, or as you put it nicely, in this teleological sense, like that's what again bothered me in Everything Everywhere. As if the reality is here in that tax office, even with Jamie Lee Curtis playing, and all these trips forth and back is just so that you return more satisfied, happy to this world. I would opt for a much more desperate solution that actors would have traveled in different worlds who are many much better than totally desperate. She ends up here with the awareness of what would have been,
I didn't see the script for that before it was made, but I did consult on the Avengers movies with Thanos destroying the world, and then they went back in time to fix it, etc. And I argued that if you go back in time and fix it, they had this multiple timeline thing, and I don't want you to eliminate a timeline. I think that's terrible. But so I said, what you should do is allow the timelines to rejoin each other so that individuals have memories of both in their future selves. But they didn't go for that. It was too complicated.
No, but that, again, the problem for me would be, I would like to rework many worlds interpretation, but I know I'm here confusing a pure physical process with symbolic one, where this would have been possible, this rejoining it, not in this sense, because as for this time travels and so on, which is a wonderful, totally pessimist version of it. I forgot the title, the British, now he's a little bit old actor, Christopher Fry. He played Oscar Wilde also in the movie.
No, yeah.
He wrote a novel which is so desperately pessimist. It's even done almost realistically, scientifically it's nonsense. A guy, a scientist, whose family died in Auschwitz, blah, 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 wants to prevent this. So he invents a rather primitive time travel machine. Not you can move up and down. Just you pick up a moment in time and you can do some little change there. So what she does in this scientist, there was in the village where Hitler was born, a small stream above, from which all the village was drinking water. So he puts around the time of when Hitler had to be conceived, he puts into the water very limited intervention, just some poisonous element which makes women infertile. So Hitler is not born. Then he steps out of his laboratory and goes into the world and finds a nightmare. Nazism developed, but instead of Hitler, somebody like Werner von Braun, a much more able scientist, became the leader and developed the bomb, and the Nazis won. So here we have a wonderful, totally pessimistic denouement. He tries to go back to bring back Hitler, so that at least the good guys will win. I love, speaking about alternate histories, there is a wonderful book that I love. I forgot the title. A whole book on alternate histories, stories about what might have happened with Hitler. There are the usual ones. He survived, went to Argentina, whatever, blah, blah, blah. Then different battles, how he might have won. But my favorite one is in his youth. Isn't this wonderful alternate history? Hitler succeeds as a painter and puts into painting his horrible visions, becomes a great modernist, becomes a celebrated artist, and end of Nazism, so on, Although this is, I know, I don't take it seriously, but it's very refreshing to think along these terms. That's all I'm saying. It was so listen. Sorry, I'm getting tired, but I really will. So you will write. You don't yet have that text.
I don't, but I'll think about it, definitely.
Please, because, okay, then can I, in quoting you, refer to this event here? Because I really want to immediately, quickly, in the chapter that you, the middlemen, know, I will add a footnote, and as not a footnote, a couple of pages, but in a sincere way. You know how we intellectuals, you are more honest, I hope so, physicists, human, you know how you cheat? I will to write a page and then I put a footnote. When I already wrote these pages, I noticed that a friend of mine hit a similar idea and so on, I will not
100%.
do this. I will do
100%, yes.
I'm really grateful for this because, no, we didn't just blah, blah. And we didn't just fraternally agree. We located the difference, but at the same time, we draw so many precise lines, because would you agree to finish in a more upbeat sense that, my God, we live in a wonderful time where the big even metaphysical questions are again arising, in the sense of, even quantum physics sees it now. You cannot just ignore it, no?
Right. And I just want to insert that if you go back to the past and change things, they, like, as you imply, they might get better or worse.
Or worse.
There's no rule that we live in the best or the worst.
Or worse, because I even read a pessimist novel about Stalinism, where Stalin is killed, but he's killed in 1935, and the one who takes over is Yezhov, his secret policeman, and it's even worse. You can imagine.
It can always be worse. Yes.
Yeah, that's, I think, my pessimist lesson also from although in Yugoslavia, communism was pretty soft, But, here also, I think a quantum approach in a general sense gives you to think, for example, I will make not just a political point, but a modest one. I was recently at a round table, in London, and there were some black ladies from South Africa. And I asked them frankly, I wanted to be honest, not Eurocentric. I said, listen, I read a lot how in South Africa, electricity cuts, the state is falling apart, blah, blah, blah. And I almost cried. One of the black ladies was so honest. He said, I'm engaged for decades in ANC struggle, but he told us that the situation is now so sad that among the poor blacks, blacks, poor in South Africa. You know what is the predominant nostalgia for apartheid? Because she said, listen, the standard of living was even a little bit better than now. They had enough food, blah, blah, now it's no electricity, chaos. It was a police state, which means less violence, some kind of basic order. And now, the black are, that now, after 3 decades or how of ANC rule, that South Africa is a country with the greatest tension between rich and poor in the world, in the entire world. And then, of course, something totally predictable happened. Another black lady attacked me, although I didn't say anything. As a racist, you don't have the right to talk about this. She played the game of you white people are responsible even now for all the mistakes. To be cynical, she played this in bad sense super determinism. You white people are responsible for all the mistakes now, And here I think this kind of alternate thinking is necessary. Like, where did things really go wrong? And I think it's too naive, because the radical leftist answer is too naive. It's because Mandela didn't go to the end. If he were to make no compromise with, but then it would have been Mugabe's Zimbabwe, only earlier there, and this is a terrifying problem for me. But we are losing time. Listen, it was such a pleasure for me. I hope that we meet again. And are you allowed, the middleman, to give me Sean's email? No, but I have it because you see it. Yeah, I have it. Yes. If I will, can I? Don't be afraid. I'm not this kind of a stalker who now in 2 hours will ask you 10 questions. I hate this. But if I have a short, precise question, can I ask you and you give me 1-sentence answer, Because you are my only... the last thing, I'm always tempted. It's sensational, but not. Is it true what many quantum physicists, which that Stephen Hawking did his real work while he was young? Lately, he was more just popularizing things. Is this true or it's not so simple?
I mean, there's some truth in that, but there's also truth in exactly the same statement applied to a lot of people who did not have a degenerative neuron disease. So I don't think that's special to Stephen Hawking.
He was obsessed with these hidden variables for decades, but it's in mid-20s that he did his great work, no?
Physics is a young person's game, no matter what your level of physical ability is.
That's why I hate, it's even historically wrong, this tendency to look at the old age, the last text or words by a big name, as if there is some final truth in them. It's totally wrong. Like, to amuse you with the last story, Jacques Lacan, when he was dying, had a young mistress, Catherine Millot. And she almost made a career out of being there at his side when she was dying. And he mumbled some things, and there was a big, oh my God, what did she mean with those? Well, what if it was nothing? It was just a confused rambling. And I see this even with many philosophers. A lot of them reach their greatest point in their middle ages, and then they just slowly go down. No? Well, I hope sincerely that in the battle of quantum physicists, you will emerge as a winner. And then exert your KGB terror to, which is when I give a talk, and usually before they ask you there, could you just say some words to test the microphone? You know what I always say? Robespierre, no freedom for the enemies of freedom. This should be our motto when we win. Thanks very much. Thanks very much. If you, the middleman, if there is something too stupid or whatever, I give you, now I will be the victim. I give you all the Stalinist right to cut it short. Do with it whatever you want. I'm not a narcissist here. I'm really a communist at this level. You know that whenever there is a conflict between an individual and an institution, I prefer to be automatically on the side of the institution because I edit some book series, and don't you hate authors who say, you throw one comma there, oh, it destroys everything, and so on, So I'm really grateful for this. It helped me a lot. My only reproach to you, Sean, is that you ruined my evening. Because I wanted to see some dirty old movie, now I will have to go into it and quickly write 2-3 pages. No?
My apologies for that. That's what I do.
No, here, your pardon for everything, but not for this. When the people get power for this, okay, I'm a good guy, you don't get gulag, but you will get 2 years of re-education camp. Get up at 5.
I could use that anyway. That's okay. Education is always good.
Yeah. Thanks very much. And again, the middleman, really, I mean it. Don't even ask me, do all the dirty stuff. All my confusions and so on. Sorry?
The middleman is not going to be cutting anything out, because this has been the middleman's most successful conversation yet, since I haven't had to speak at all.
But I like the middleman, the term. You know why? Because do you notice how today people don't like authority? I always like authority in the sense that sometimes you need authority in a debate when it goes well. But today, already at the level of words, it gets confused. No longer likes to talk about director, leader. The favorite term is coordinator, It sounds, you keep all your power, but it sounds much more innocent, I'm just coordinating things, So I know, and that's why I still have hope in Iran. I have connections there on the opposite side. And they told me, still you cannot compare Iran in spite of all that's going there now with something like Saudi Arabia. Women were able to protest precisely because they have a strong role. For example, it's a common joke there that the big guy is a minister, usually a man. Although even this is not the case. You have 1-2 feminine ministers in government. But immediately, when you make a business deal, you discover that the minister is an idiot. And you have to talk with persons around him who are in majority women. Don't underestimate Iran. It's tremendous. They are so crazy, they translated 15 of my books. It's intellectual. No, this is not a good sign for them. It's a sign of confusion. What I want to say is that it's intellectually alive. While in other countries, Egypt and so on, it's very tragic how little they translate. They simply don't have this humanities, social sciences life that we have,
The history does matter. The histories there are very different.
Yeah. But as Iranians point out, they are not simply a Muslim country. They are Farsi, Persian, and they always proudly point out, we are not Arabs, Yeah. Sorry for this racism, because today you never know what will be proclaimed as racism,
Yes, thank you both. This has been a blast. Hold on, Geeslings. Before you go, please like, subscribe, follow if you haven't already. Smash all those buttons. And also, if you haven't followed me on Twitter at Robinson Earhart, or if you're not joining me every morning as I eat my pint of ice cream on Twitch at Robinson Earhart on Robinson Eats, please do so.